I think Dr. Shanoy, you had a couple of what do you call meetings.
Yes.
And I was also a director NIOT, sir, before he took over director in COIS.
No, it was I joined as a director in COIS in 2009. Then in between about 2.5 years, I had both institutions with me.
Yes.
You, Dr. Shanoy was with the NIOT, right?
I was at NIOT also. I was director there for 2.5 years.
I'm appearing in two screens, and I think what's happened is, okay, I'll cut off and start all over again.
Yeah, I think you must have logged in from two devices.
I think we'll get started, sir.
Yeah, it's fine.
10:30. Good morning, everybody. Thank you all for joining us. This is a series of presentation. This is a culmination of our summer internship. We run basically two programs. One is internship program and a summer school. This time we could not run the summer school for multiple reasons, but the internship program is a very strong program. I must tell you, we get about 500 applications from all the top IITs, and my team has a very difficult task to cut it down to a much smaller number. This time we had 16 interns who have worked with us, and it's been a two months program, ably run and coordinated by Sridhar Prabhuraman, Catherine and Ananya, and also ably supported by Shreya and other MRC engineers. And also Nishtha has been coordinating various activities. And I must also introduce the panel which will be there. Ambassador Mudgal sir is here. Sir was Ambassador of India to Mauritius. Very significant because that's when the Sagar Vision was declared by the Honorable Prime Minister. Sir has very keen interest in blue economy, and he has a lot of study on the subject. Sir is also now the co-chair of the Blue Economy Task Force of FICCI. He has been part of the various very top level decision-making bodies, even the Prime Minister's committee, he has been part of it. So thank you very much, sir, for being here. And sir has been a very, very close mentor to MRC. I would also like to introduce Admiral DSP Verma, sir. Sir has been my personal mentor, but he has been extremely kind to MRC right from the beginning. And we have been taking various aspects forward and always reaching out to sir for guidance. And sir has been extremely kind. Sir was the chief of material in the Indian Navy, and which is the highest technical post, as you all are aware. And we have also, sir was the Director General of the Nuclear Submarine Project. So a very, very important assignment where he was instrumental in the launch of the nuclear submarine. And but he has post that also, sir has been involved with various startup initiatives also and guiding multiple people. Then we have Dr. Satish Shenoy, sir. Sir has been in the scientific, I mean, he represents the scientific community. As we were just discussing, sir was the director of INCOIS, International Center for Ocean Information Service. The entire digital ocean initiative of the government of India is being driven by INCOIS, a very important component of Ministry of Earth Sciences. Sir has also been the director of National Institute of Ocean Technology, and they are responsible for various underwater technologies that the nation requires. And sir has been part of the blue economy policy draft So I draw a lot of inputs from sir and a lot of guidance from sir on taking these the UDA framework forward. So thank you all for joining us. Ashwin Bhai will probably join in a while. Even Captain Subedar will join us in a while. We also have Dr. Shrabana Barua, who's a strategist and geopolitics and international relations expert. Her main focus has been on multilateral relations and multilateral frameworks. And also we have Mr. Deloitte Noral from France. He's a researcher from Paris, now with the Observer Research Foundation in India. His interest is Indo-Pacific. As you know, we are reaching out to various think tanks and various organizations globally. So I thought this is a good opportunity to also invite people like him. And there will be many people joining us online, and this will be reaching out across, and the recordings will also be available. So without taking much time, I'll hand over to Nishtha to take it forward.
Thank you so much, sir. A very warm welcome to everyone. Good morning. I'm Nishtha. I work with MRC at the capacity of a communications and advocacy lead. And I would like to welcome you all for today's presentation, especially the dignitaries that we have today. So as part of our endeavor to offer a holistic learning experience for the undergraduate and postgraduate student community, MRC offers internship and fellowship opportunities to the concerned institutions on a very regular basis. During the summer internships, the interns are exposed to the UDA framework, its challenges and opportunities. They are guided through detailed literature surveys and encouraged to formalize their specific project topics. I would also like to inform that today the summer internship for this year is coming to an end today. So for the upcoming 4 days, including today, we will be having a series of presentations by interns and fellows. And further, on the day 4 of the webinar, which will be held on July 21st, our fellows, including Catherine, Aradhya, and Devyara, will also be presenting. And during the 4-day webinar, we will have presentation by our interns and fellows on various topics, and I would say pertinent topics, including the economic impact of climate change on shrimp farming, the Indian Ocean region, ocean acidification, etc. Our interns will also be presenting on other topics, including the groundwater management for the Brahmaputra Basin, the impact of water quality, change in aquaculture, urban flood management, etc. Now, as we are about to begin our presentation, first I would like to talk about some of the ground rules for all the presenters who are here today. So dear interns, please note the following and adhere to the time limit that has been allotted to you. The number one thing to keep in mind is the duration of your presentation must not exceed 15 minutes. Second, we will take all the questions after all the presentations have been made. So for the same purpose, I have shared a working Google Doc link with all of you. So all the participants, whoever have any questions, you can post your questions over there. And after all the presentations get done, we can take up the questions one by one from there on. Also, 2-3 minutes between each presentation is accounted for additional extra time and takeover by the next presenter. Fourth, and the last one is that each intern and fellow must introduce themselves and talk about their affiliation and research project before starting their presentation bit. So that's it from my end. Before we start the presentation, I would like to call Sridhar, who has been managing the internship program at MRC from end to end, to speak about his experience of conducting the presentation and how the internship was and all that. So Sridhar, it's all yours.
Thanks, Nishtha. A very warm welcome to all the dignitaries present here. We are extremely happy to have you with us. It has indeed been an end of a 2-month-long journey that we've had now. All these interns who are undergraduates belonging to some of the best institutes in the country, and of course the fellows that have been here for a long time now, have put a lot of hard work and dedication to each of the project that they have done. Every result that you see today, every presentation that you see today has been the hard work of the interns that have worked day and night over the past 2 months and have done a fantastic work on all these projects. Today specifically, we'll be looking at projects involving marine spatial planning, focusing more on sediment classification, sediment management, noise mapping, acoustics in general, and the projects that we derive from that. And of course, machine learning being one of the most dominant trend that is happening nowadays, we have focused a lot on inculcating the use of machine learning and AI as a technology into the underwater domain awareness framework. And over the upcoming 4 days, you'll see a lot of projects that involve machine learning and AI, and how we verify and validate a model. Things that would bring an extreme amount of new things to the picture in the underwater domain, and that would allow us to validate and work better in terms of as compared to the existing models that we have. So again, thank you everyone. And without further ado, I'll request Sanskar to start his presentation, please.
So, hi everyone. Good morning. It's a great pleasure to present my work in front of such a personalities in the field of maritime domain. And let me start with sharing the presentation. So, hi everyone. This is Sanskar, and I am a fourth year undergrad and a final undergrad at IIT Delhi. Working I'm pursuing chemical engineering, and it's happy to announce that I'm so much interested in maritime domain that my final BTech presentation and the final BTech project in my college is related to maritime domain, and also in MRC I'm working on three-dimensional ocean ambient noise mapping, which is a dynamic mapping across horizontal and the vertical dimensions, which actually creates a very good visualization to map the areas with the high noise, and to protect the marine environment, and to certainly it creates an effect in the economy also with the government. So these are the contents I'm going to cover, like what are the ambient noise in ocean, 3D ambient noise mapping, and why we need it basically. Program explanation, what we did, and what further steps can be taken. Like it's the first version we have built, and like so many updates can be there. And a quick demonstration of the project. And this project comes under the marine spatial planning. So how MSP, how we use the MSP in creating the project, and how we can use the software further in various aspects and various sectors. So coming to the ambient noise, so it is basically the background noise created by various natural and human activities within the marine environment. So when we come towards the natural sources, there are waves, winds, rain, and there's like which affects the marine life, such as fish, whales, and dolphins, and also the human activities like offshore drilling, seismic surveys, maybe the submarine sonar systems, and the changes in ambient noise levels can deeply impact the marine life, as this is a main channel of the marine life to communicate with each other and to feed, migrate, and all of that. So why we need a 3D ambient noise mapping, right? So like it creates a spatial distribution between the horizontal and the vertical dimensions, which actually certainly give us a open hand to analyze and to view how the noise is changing. Like there's not much change in the vertical dimensions, but if we do the color coding very sensitive, and we can see a very good change in the vertical dimensions also. And there are so many mysteries in the ocean which can relate from that. So it also helps and identify and characterize areas with high ambient noise levels, which can help us certainly to analyze the implications on marine life, and particularly the sensitive species. By mapping ambient noise in 3 dimensions, it enables assessment of noise source and their potential impact across the depths and the locations within the ocean, like latitude and longitude, and across the depth within the certain defined depth we have. And such mapping can assist in developing effective noise mitigation strategies and the regulatory measures for the government and for the industries also. These are the tool basically. This is a front end. That's how we map the 3D noise currently in a Plotly environment, and this is a 2D version for the same. Continuing with the technical aspect of the project. So this is the flow of the software we have built. So we gather the live AIS data and we plan to gather live AI's data. Then we pre-process the data according to our needs, like in what format I need the data and what data basically I need. Then we calculate the source noise from the AIS data with the specifications needed, what kind of ship it is, what's the weight, and the coordinates of the area then we calculate the coordinates of the area, which is a dynamic thing which we offer to the user, and then we generate the grid which is 0.25 degree apart from each other, and then we calculate the ship coordinates which we gather from the live AS data from each receiver, which are under 200 kilometers from the each receiver, which certainly give a brief idea of what noise can be generated at that particular receiver point. And then we pass this data to the artificial neural network we have built to calculate the transmission loss for each pair of the receiver and the ship. And multiple ships are under the one receiver. And then we calculate the noise level at that particular receiver. And then we 3D visualize it with the Plotly environment of the Python. Then we render it on a web page, and we present it with a color coding so that it's easy to analyze and it's easy to visualize the way it is. So this is the main focus we put on the data structures used. So when you or when you use Google, you basically see what are the restaurants under 20 kilometer around me and what are the hospitals 20 kilometer around me. They use the same data structures, and we have also used the same data structure to quantify what are the ships around 200 kilometer under a receiver. So it's a dynamic thing, and we can change the range as per our requirement. So basically going through the arteries is basically the spatial mapping, or say spatial data storage data structure we use, and it basically helps us in the basic of intersection, in the basic concept of intersection, like we have covered the area already, then why we cover it again. So this is the most efficient way to use in the spatial and the geospatial mapping. So what steps need to be taken in the further, like we have to integrate the live AI's data, and to make the code and the software efficient and fast, making the searching algorithms fast, making software dynamic for depth, like as if now it is 75 meters, then we can make it dynamic according to the change in environment, making some algorithms fast, like because it is the most costliest algorithm in our software right now, because like there's a lot of millions of ships right there, and to calculate each noise it takes it is costly. So 3D map on the surface of the ocean, like basically making it live on the surface of the ocean, so that basically you can analyze it on the surface of the ocean rather than analyzing in a broadly environment. Inclusion of wind and the sedimentation noise, and this is a nature generated noise as we discussed previously. So this can be integrated in the system, and this will give a very accurate result for the noise. So just a quick demonstration, if I can confirm like it's visible or not.
Yes, it's
Yeah.
visible.
Okay, thank you. So now getting forward to use the tool, like it's a dynamic thing. So we select the area, like just we select the small area right there. So it dynamically selects the coordinates, the area we have selected, the end and the start coordinates. And you go to the generate noise map. It goes to the backend here, and it started getting generated. So these are the backend we have performed, and this is how it generated, and we can surely analyze it using the color coding algorithms we needed, and across the depth, across the latitude and the longitude, and inside it also. So at different sides you can see the color changes right here. So these are the noise levels which are very high, and these are something where the shifts are not that much. So going forward, how we use the MSP, as it comes under the MSP, and we are talking about the marine spatial planning. So what we did is we defined the objective and the scope of the project. After that slide, we will discuss how it can be the use and how it can be beneficial for the stakeholders, gather the data information, assess the current state as there's no such tool exists, engage stakeholders, analyze data and the stakeholder input, evaluate the environmental impacts, what can be the impacts it can have, assess socioeconomic factors, develop the MSP plan and implement the MS plan. And the most important steps come here is the monitor and evaluate and the review and update, because in the each product you develop in this industry or in the corporate world, you need to come with a feedback, because certainly it reflects the user requirement and that's what they need. So where we can use it basically, like in the shipping and maritime, we can see the software can assist in mapping and monitoring the noise generated by the shipping activities, as well as commercial and the cruise ships. Like we can have a further version of this model with a filter of what kind of ships I want to visualize, what kind of ships generating noise and underwater construction. During underwater constructions project like bridges, piling of underwater tunnel, and like the software can help visualize and predict the noise propagation and marine protected areas. Mapping ambient noise in marine protected areas helps us with the condition potential impacts on the protected species which are in the on the way of endangered species, or which are in the on the verge of extinct. So in marine research, scientists studying the behavior and the communication of marine animals can use the software to analyze. So it basically can analyze where the noise is getting higher. So there can be the a lot of marine organisms can be there, and they can migrate. So they can track the migration of the marine organisms. So offshore energy, the software can be used to assess the noise impact of offshore wind farms and the oil and gas platforms, the tidal energy installations in the marine ecosystem. So this is the end. There's a quote by Marina Reed. So amidst the symphony of the ocean's ambient noise lies a delicate balance between nature's harmony and the human intervention, which you are trying to do. So 3D ambient noise mapping, we strive to uncover the hidden melodies of our marine environment and orchestrating a future where industry and ecosystem coexist in harmony and benefit each other. So, thank you. It's
Thank you. Thanks, Sankar. Next, we have Akshita Mangal from IT Delhi with us. Akshita, you can share your screen.
Yeah. I hope my presentation is visible.
Yes.
Okay. Hello and a very charming morning, everyone. I'm Akshita Mangal and I'm a third year right at IIT Delhi. And I'm pursuing my majors in mathematics and computing. And I'm currently a research intern at MRC. AI powered prediction of ship noise parameters using real-time AIS data. So before diving deeper, I would like to give you the contents of the upcoming PPT. This is introduction, need, the problem, the impact, the solution accuracy, future scope, followed by the conclusion. So before starting, I would like to give you some background information on what exactly I'm going to present and to give you some definitions of the things. So basically, the source level of an ocean refers to the intensity or power of sound generated by various sources within the ocean environment. It is a measure of the acoustic energy released by these sources. You'll slowly able to know why I'm giving this definition and how it is related to the project that I have already done. So the source level is typically expressed in decibels and represents the sound level at a specific distance from the source. The source level of an oceanic region is directly related to the noise level experienced in that area. So we can see that there is a relationship of the source level and the noise level. If there are high intensity sources or multiple sources of sound, the overall noise level will be elevated. Now, the sources of noise in the ocean can include biological sounds like marine mammal vocalizations, fish sounds, and the movements of marine organisms. Additionally, physical processes such as wind, waves, and rainfall also generate noise. Human activities such as shipping, seismic surveys, sonar operations, and offshore industrial activities also contribute to the overall noise level in the ocean. So by measuring and assessing the noise level, scientists can actually study the acoustic environment. They can evaluate the impact of the noise on the marine life, maybe their migration, their habitat, and their locations, and develop strategies to manage and mitigate potential adverse effects. Since noise, or you can say very high amount of noise, is not good for the marine life and the acoustic environments, we can actually develop some strategies and some measures through which we can control this noise. So it basically provides a quantitative measure to understand the background sound conditions in different oceanic regions and monitor the changes that we have over time. So understanding the source level and its relationship to the oceanic noise is important for managing and mitigating the potential impacts on marine ecosystems. Scientists and policymakers study and monitor these sound sources and their effects to develop measures that minimize the disturbance to marine life and maintain a healthy ocean environment. So what basically this relationship between source level and noise level is? And here we have. So there exists a mathematical relationship between the source level and the noise in the context of ocean acoustics, which can be described using the inverse square law. According to this inverse square law, the intensity of sound decreases as the distance from the source increases. And the mathematical relationship that we have is basically the noise level, which is exactly equals to the source level of the sound source, the transmission loss, and there are some additional factors or the corrections that we have, such as the absorption and the scattering losses. So in this equation, the source level represents the initial intensity of the sound source, while the received noise level represents the sound intensity at the receiver's location. The term TL accounts for the attenuation of the sound energy due to the spreading of sound waves over distance. So TL is basically the transmission loss that we have. Now, as I've already established the importance of source level and noise level and how they're interrelated, we have concluded, or you can easily conclude, that there is an importance for the measurement of source level. So we have some different models for its calculation, and I'll name them the Wittiken model, Norris and Harvey model, Harbor Porpoise model, sonar performance models. I would like you to note that there is nothing called the best model because their usage depends on the application and the interest area that we have. Like we have this Norris and Harvey model, which is actually used for something like for pile construction for source levels. For sonar performance, we have the sonars level source level predictions and calculations. So there's nothing like called best model, but we have different models for different purposes. So it's important to note that specific models and methodologies can vary depending on the particular source of interest and the available data or information. These models also provide a foundation for estimating source levels, but their application may require different adaptations or refinements on the basic specific context and the requirements of the study. Now, why I'm focusing on the Wittiken model is that because we are actually studying about the IOR, which is Indian Ocean regions, and it has a kind of very important application when it comes to different trades and the different ships that they go there. So the major noise that actually contributes to IOR is because of the ships, and that's why we are studying about the Wittiken model, which is actually known as Wittiken-Kinstler model and is widely used for estimating the source level of ship noise majorly. It takes into account different parameters such as ship speed, ship tonnage, propeller characteristics, and the operating conditions. So now what is exactly the problem here? The problem is that we have a lack of accurate and real-time estimation model. So basically we have some data, but we don't have the real-time data because we need to calculate the source at a particular time, the noise at the particular time, and for that we need the real-time data and their accuracy, and their accuracies should be also high in order to calculate the noise level. This can also be used to detect some dark ships which are not good for the marine life, since this noise actually contributes with the marine environment and is not good for the marine ecosystem. We can actually detect such ships and can discard them or can alert them in order to change their shapes, or maybe just for having some mitigation strategies we can use them. So the parameters that are not there that we cannot calculate are the engine power, the engine mass, number of engines, cavitation speed, block coefficient, and Froude's number. These are the parameters that are required for the Wittiken model in order to calculate the source level, and we cannot get them through AIS. So we need to do some calculations behind them in order to get them also, so that we can put them as the inputs, and finally we can get the source level as the output. And thus availability of such data is essential since they are crucial inputs for accurate source level calculations. Now, before getting to the solution, I would like you to highlight or to just pay attention on what impact this study can make. So firstly, it will enable a comprehensive assessment of ship-generated noise and its potential impact on marine ecosystems. Accurate estimations of the source level provide a foundation for understanding the acoustic environment and formulating the effective mitigation strategies. Secondly, the real-time estimation of ship parameters facilitate timely decision-making, very important for environmental management and regulatory frameworks. Last but not the least is the ability to predict engine characteristics and hydrodynamic properties, which enhances our understanding of noise generation mechanisms and supports advancements in ship design for noise reduction. So obviously we can make changes in the designing of the ships in order to reduce the noise generated by them as much as possible. Now, what's the solution? So in my study, I've actually developed a kind of predictive model that utilizes the real-time automatic identification system, that is AIS data, to estimate engine mass, engine power, number of engines, blocks coefficient, frauds number, and cavitation speed. So by leveraging AI-driven algorithms and advanced data analysis techniques, so this model aims to overcome the limitations of existing approaches and provide accurate, promising results, I would say, and timely estimations of ship parameters. So what exactly this model is? This is a random forest regression model and to predict the ship parameters based on the real-time AIS data. Why I've chosen this random forest is coming in the next slide, but here just an introduction. That random forest is a powerful ensemble learning algorithm that combines multiple decision trees to make accurate predictions. The random forest is suited for this particular task because it can handle some complex relationships between the input features and the target variables. So the target variable that we have here is the source level, and the inputs that we have actually will get 3 inputs from the AIS data, and the rest are actually the predictions. So we'll finally have the this ship, this engine mass, the engine power, and all those things as the output. And these outputs can be further given to the Wittiken model, and then we have the source level. So this random forest actually reduces the overfitting by training each decision tree on different subsets of the training data and a random selection of features. This diversity ensures that the model captures various aspects of the data and reduces the impact of individual decision trees biases. So the proposed model will enable more precise assessments of the source levels using Wittiken model, contributing to the understanding and management of ship-generated noise pollution in marine environments. Now, how is actually the data and the methodology of the code, or you could say the model is? The data that I've got is from the MRC itself only, and here goes the methodology, or you could say the flowchart that the code actually follows. So firstly, the data is loaded. So it takes the data in the form of Excel file and then stores it in a data frame. Then the data preprocessing is done, since the data that we get cannot be completely utilized by us because it can have some kind of flaws in it. So before getting into the results, we need to process the data, and this actually includes the conversion of column names to string for the consistent data types, dropping some irrelevant columns, since this AIS data consists of a lot of other features as well, a lot of other data as well that is not required for the training purpose. So we discard those columns. The data frame is actually split into the input features and the target variables, and handling missing values, and finally encoding categorical data. Since random forest is well suitable for numerical data, we use a technique called one-hot encoding, which converts this categorical data into the numerical data for our purpose. Then comes the data splitting. The data is split in the training and the testing sets. The model creation and training, it actually create an instance of the random forest model, and finally it is trained on the data set that we provide to it. And finally, it predicts the different ship parameters that I've already stated. And these predicted values are actually extracted from the predictions. And then we have this outcome of the basically predicted values. And in order to calculate the that I've used, which are actually the MSE, which is the mean squared error, mean absolute error, and 2 squares are also calculated and they're printed. Now here comes a kind of, this is the snippet that I've taken from my code, and these are the results that I'm getting from the data set that I've used. Mean squared error is basically 74.19, which indicates that the average square difference between the predicted ship parameters and the actual values in the testing set. The mean absolute error is 0.48, which is pretty low, and it actually indicates that the model is giving you a kind of promising results. Represents the average absolute difference between the predicted ship parameters and the actual values. It provides an estimate to the average magnitude of the errors made by the model. And then we have the output score, which is 0.18, indicates the proportion of the variance in the target variables, basically the ship parameters that can be explained by the model. So it represents the goodness of the fit of the model of the data. Now, because this study is not yet complete, so we do have some future scope in this field. So the future research actually indicates that Anyone could focus on further refining and optimizing the prediction model, since this is not complete, I'm saying it, and encompass a broader range of ship parameters and incorporate additional data sources. So this whole model has been developed keeping in mind the vertical model for the generation of source level. But in order to calculate different other parameters, we can still use and can get the data set that includes some different parameters other than these parameters, and can additional have some other data sources, and finally we can develop this model, or maybe do some kind of innovation in this existing model. Additionally, the efforts can be directed towards enhancing the integration and automation of the prediction model with existing underwater noise assessment frameworks, such as the Vatican model, and maybe we can use some other model as well, but this is the model that is fit for our purpose, to enable real-time monitoring and rapid decision-making process. Apart from this, the data used for training model was of a specific place, as I mentioned, that it was for Iowa, the Indian Ocean region. One can use a broader and larger data set in order to generalize the model. This was a bit specific model, but you can actually use it or change it according to your customizations to incorporate other changes as well. So the conclusion can be that the development of our random forest model addresses the need for faster calculation of ship parameters required by the vertical model. And by accurately predicting the ship parameters based on AIS data, our model expedites the estimation of source levels in underwater acoustics, facilitating timely assessments of ship-generated noise. This contributes to the effective management of marine ecosystems and supports sustainable governance strategies. I would like to wrap up with a quote saying that health to the ocean means the health for us by Sylvia Earth. Thank you so much. Thanks and have a nice day.
Thank you, Akshita. Thanks for keeping the presentation very quick. Next, can we have Akshay Mondal from IIT Kharagpur with his presentation? Hi, Akshay, are you there?
Hello.
Yes, you're audible.
Good morning, everyone. I am Akshay Mandal, a third-year student at IIT Kharagpur studying mechanical engineering, and I am a research intern at MRC, and I'm going to present my project on the topic low frequency, wind and precipitation noise mapping. This is the flow of content I would follow. First, I would give a brief introduction of ambient noise mapping and why it is required. Then we would go through the description of the intermittent noise sources, more specifically the wind and precipitation noise, which affect ambient noise in low frequency region. Then I would describe the methodology I followed in doing this project. After that, we would see the results, analysis of them, and finally we would end with the limitations, applications, and the future scope of this work. Underwater noise estimation is the modeling of noise sources and studying the impact in the region, which in our case is the Indian Ocean region. A major impact of underwater noise is on the marine animals and the ecosystems. The marine animals use sound waves as means of communication and gathering information about their environment. However, over the last century, ocean noise levels is rising due to various activities. This is negatively impacting the ecosystem and ocean animals. They are losing their communication ability and ability to hear vital environmental cues for their survival. Here we observe the sound level with a frequency plot of various possible noise sources in the underwater domain plotted by GM Wentz. It clearly shows that the dominant noise in the low frequency region is the shipping noise. So estimation and regulation of shipping noise is very important in this aspect. However, the shipping noise estimation is also impacted by some intermittent noise sources like wind and precipitation. Some major intermittent noise sources which impact the ambient noise are wind and precipitation noise and noise from human activities. Wind noise is dependent on the wind speed blowing over the region, and it varies over the frequency range of 500 Hz to 50 kHz. Precipitation noise varies according to the raindrop bubble size impacting on the ocean surface, and it produces a wide frequency spectrum noise. Human activities like fishing, leisure transport, and industrial activities like oil drilling also contribute to noise pollution. is a major contributor to ambient noise in underwater domain. When waves break due to air and sea surface interaction, wind noise is generated. When the waves break on impact on the sea surface due to ocean, bubbles are formed. These bubbles conglomerate form bubble clouds within a few meters under the sea level. On reaching a certain concentration, these bubble clouds propagate in radial directions, affecting ambient noise in the low frequency region. Then we come to the precipitation noise. Precipitation or rain noise directly depends on the total rainfall rate in the region. It is characterized as a continuous broadband noise with a sharp peak at 14 kHz, and it generally lasts for several hours or sometimes even days. Rain noise is generated in two ways. The raindrops fall from the clouds and impact the sea surface, generating a spectrum of white noise. This noise is dependent on the raindrop radius and the impact velocity of the raindrop. And another way is the oscillating air bubble formed due to the impact of the raindrop. Small raindrops, which have diameter less than 1.1 millimeter, produce a broadband impact sound, followed by a louder sound due to the damped oscillation of the bubble formed due to impact. Medium-sized bubbles, which have diameter between 1.1 millimeter and 2.2 millimeter, are relatively quieter. Large raindrops, again with diameter greater than 2.2 millimeter, produce a loud impact sound. Now we come to the methodology followed in doing this project. First, I created a grid of ocean coordinates using the shapefile of Indian subcontinent. Then the wind speed and precipitation data is loaded into it. Time series data is fetched from Omni and Rama weather buoys deployed in the Indian Ocean region. Missing timestamps are interpolated by mean interpolation. The wind buoys covered only 10% of the coordinates. So for the covering the rest of the coordinates, they are calculated using iterative weighted distance interpolation method. It estimates the weather data at unknown coordinates by calculating the uh, data from nearby known values, which are inversely proportional to the distance. The closer points have a higher influence on the interpolation, while further points have lesser impact. Finally, wind and rain noise models are applied on the data. The output of wind and rain noise is then added logarithmically to get the total intermittent noise. This total intermittent noise is then added to the shipping noise to get the total ambient noise in the low frequency region. This is the noise map produced of the Indian Ocean region. Here we can see the legend, and this is for a frequency of 1 kilohertz. And we can see the total noise varies from approximately 55 decibel to 75 decibel. Now we'll see a time series animation of the noise map at one frequency over a time range. This is what I made. This is the live data. From here, I have to select the filter as timestamp, and then here what I want to do, we can do individual of rain noise, wind noise, and I have currently selected total noise. So then I will play this, and it gives a animation, starts the animation. And this can be expanded for better visualization to other time ranges and to other oceanic regions also. After that, I come to the result analysis. The wind noise rise in the 40 to 60 decibel region, and the precipitation noise in the 60 to 70 decibel. While calculating the total natural noise, it lies in 55 to 75 decibel, which you can see from this plot. The below is the wind noise, and the green color is the rain noise, and blue color is the total noise at frequency 1 kilohertz. This is data for a single site at given coordinates 10 degree north and 70 degree east. Finally, I plotted the noise at different frequencies over the time range. We can see that on increasing the frequency, the sound level decreases. And while we add this noise to the shipping noise, which is generally in the range of 100 to 130 decibels, we see that it adds very insignificant amount to the total noise, ambient noise contribution. Now we come to the limitations of our project. The rain rate measurement is not accurately possible in the seas, and hence any rain noise model is prone to errors. Other intermittent noise sources like industrial activities like oil rigs and human leisure activities are yet to be accounted for in the total ambient noise mapping due to lack of the data. And complete data is unavailable, and computer vision techniques are used to extract them, which always don't give error-proof results. Finally, come to the applications and future scope. Regarding application, we can always study the impact of the noise on marine organisms and take mitigating strategies to improve them. This also helps in improving the sonar efficiency for its use in submarine and underwater vehicle navigation system. We can also determine the signal to noise ratio in the underwater domain. Regarding the future scope, we can incorporate other possible noise sources like industrial noise from oil rigs through on-site data noise collection. We can also include more ship parameters in shipping noise mapping. Finally, I would like to conclude with this thought that of all the varieties of modern pollution, noise is the most insidious, and we must take steps to curb it. Thank you.
Thank you, Akshay. Next, we have Romit Kavre with us, who is an MRC fellow and is also a student at IIT Delhi. So, Romit, the stage is all yours.
So good morning, everyone. I am Romit Kavre. I recently graduated from IIT Delhi with my bachelor's in civil engineering. So my journey at MRC was right from a third year internship, and then I rejoined as a fellow in order to take my work forward, which is basically the sediment classification and its application in the Indian Ocean region. So this will be the agenda for the today's discussion. We'll talk about the sediment classification, three broad domains of consideration, and then we'll go on seeing what is the current scenario, the current challenges that are being faced in the region and in India for the sediment classification techniques, and then what are some future prospects for these particular challenges. So the first question that comes to our mind is why we should really study the seabed. So the seabed structure is a result of millions of years of the natural process of weathering, sediment transport, and all, and it plays a very crucial role in influencing the various biotic as well as the abiotic components of the marine ecosystem. So the various recreational, defense, economic related, or ecological purposes all have these applications of the seabed. Apart from that, in order to have proper monitoring and conservation plans of the various ecological assets, the marine ecological assets, it's very important to know what is the current scenario, how are they getting changed to the various human interventions and all. So all these require proper knowledge of the seabed, and that's why the knowledge of a sediment is very crucial. Now this sediment knowledge is very much has a lot of application in a broad range of domains, like being the sediment bearing pressure, the benthic ecosystem, or the abiotic element detection, which will be like talking about them. Apart from them, there are the underwater cable route laying or the submarine route planning, and then in the isolated areas of the Indian Ocean region as well, there are a lot of mineral deposits. There are possibilities of oil and gas exploration, and then there could be chances of recovery of debris and marine litter as well. So all these have a like the sediment classification techniques have a broad range of aspects. So when we come to our first application, that is the sediment bearing pressure. So it is basically the maximum capacity of the soil that it can have with excessive deformation or settlement. Now it is characterized by the various geotechnical properties of the sediments, the grain size distribution, the density, porosity, and other geotechnical aspects. And it is a crucial understanding in the way in the when we come to the offshore construction part. So in designing any of the offshore construction, say with the oil rig, uh, there would be drilling rigs, refineries, or some constructions like the sealing, Mumbai Bandra Worli sealing is there. So all the foundation design is one of the most crucial tasks, and in the sediment bearing pressure again has a very important aspect in it. There have been various instances across the globe where they have used the sediment bearing pressure in order to design safe structures. It also has various defense related applications as well. So like in deployment of some amphibious vehicles, or in shallow water warfare, the sediment bearing pressure plays an important role in deployment of such assets as well. Then comes the benthic ecosystem. Now, it basically refers to any of the ecosystem that lies in the lowermost region of the water body. It is crucial to know the current know-how of what is the level of these benthic assemblages, because they tell us the quality of the marine life that is there. Uh, so it also helps in the nutrient recycling of the water body as well. And apart from that, it also has implications on the various marine life of aquaculture, there is fisheries as well. And again, this could be understood in order to find how these benthic assemblages vary with the increasing fluctuations of say climate change. There is global warming, ocean temperature rising, and then developing a future time scale prediction of how can these vary based on the human interventions. Then comes the abiotic element detection. So it basically refers to the part of the ecosystem which are not part of the natural environment. So it may involve the shipwrecks are there, marine litters are there, the various polymetallic nodules, mineral concentrations and all. Uh, but we will be mostly sticking to the marine litter and the polymetallic nodules. Again, as we know that our oceans are facing a lot of issue of marine litters, like around 100 trillion microplastics are still found in the oceans, many of them lying on the seabed, which affect the marine life and have directly or indirectly entered the food web, also harming the humans as well. Also, the Indian Ocean is rich in these polymetallic nodule concentrations, which are very much crucial in the novel battery types, and so it has an economic aspect as well. Now, coming to the current scenario, we must understand that data collection is one of the most crucial aspects in developing any of the future aspects, future distribution or monitoring techniques. So conventionally, there are these grabbers and corers that are used to, or the borehole samplers that are used to collect the sediment data, and then based on our needs, laboratory testing is done. But with the development of modern age technologies like acoustic sonars are there, optical sensors and waterproof cameras and all, which could be mounted on various submarine ships, or again autonomous vehicles, the remotely operated vehicles. These have led to a huge coverage at very low cost. And again, this computational simulation and modeling tools have also been developed in order to have a very large or very broad view of the seabed as well. So all of this is quite crucial. We are understanding, but again, why we should consider the Indian Ocean region? So again, Indian Ocean region is surrounded by a lot of it's a very complex in a complex situation. It is surrounded by various nations. There is political instability. There are conflicts. There is just deficit. Apart from the Indian Ocean is the one of the most diverse region. Being tropical waters, it has a lot of diversity of flora and fauna, and marine life is bustling here. The climatic conditions in the Indian Ocean region are very much varied. It has a lot of fluctuations. We have the monsoonal winds, a lot of cyclonic fluctuations are there. All of these lead to the suboptimal performance of the various systems that are deployed. So in fact, it may reduce the performance of the acoustic sonars by around 60 to 70%. So there needs a proper development strategy in the Indian Ocean region. So coming to it, what are the various challenges that are facing in the region, as well as when we consider the Indian perspective? So the first thing is there is a no proper holistic regional cooperation. So even though there are the multilateral frameworks that are there, but again there is no common identity when it comes to again the sediment classification systems and all, because again various countries have the various ambitions. So say Israel may have their ambition in the maritime security, while South Africa or Australia would have some more in the ecological domain. So there is no proper coherent voice amongst regarding this sediment classification systems or the marine assets as well. Again, when we see the region, there is a capability imbalance. While some countries have some higher levels of capacity buildings, when we consider South Asia, India have a lot of capacity building expertise, but again, there is also a lot of challenges in the human resource development. There is a gap between the academic degrees and the industry level standards that are required. Lack of technical expertise is there among the various regions of the in the Indian Ocean region as well. So one of the major thing is that when we talk of the region as well as India, there is no proper central monitoring authority. So a lot of research expeditions, data collection expeditions are conducted, but again, there is no proper monitoring authority which can oversee what kind of hardware they are using, the quality control mechanisms and all. There is no proper guidelines or the standard operating procedures in case of any hazard as well. In fact, when we see that all of the, if any of the development works needs to be done or any research study needs to be taken care of, we mostly rely on the Western organizations or the innovations that have been developed by them. Directly using them in the Indian Ocean region is not a very good idea, because again, they are catered to their oceans and not the Indian Ocean region. As I mentioned, the performance also drops. So again, it also leads to have some economical aspects, performance related challenges also come up, and it again, there is a proper need of developing solutions specifically for the Indian Ocean region. With the we have seen the Malaysian Airlines MH370 disappearance. So it's been a very it's a mystery still now. And in order to understand where the debris is there, the researchers had to first had around 1 year in order to have deep sea bathymetric charts readily made, in order which took around 1 year, and then they basically had these ROVs and then AUVs deployed. So even the data collected constituted for around just 1% of the Indian Ocean region. Uh, there have been rise in the what we call the dead zones along the Indian Ocean region as well, or the Indian boundaries as well, which have led to serious stress on our ecological assets, and there have been calls for having proper monitoring and conservation efforts. We have seen the current case of the Titan submersible, how again various ROVs were also deployed. Well, the Indian Ocean region lack in such aspects, and so there is a very much possibility in developing such systems for recovery of debris and all. The Indian Ocean has a vast potential. So, what can really be done? The first thing is there should be enhanced regional cooperation. There should be common SOPs could be made in terms of any of these natural calamities or disaster. The current multilateral frameworks could be strengthened, like the IORA and BIMSTEC. They could talk about the various uh, aspects of the underwater domain awareness, the marine spatial planning, and incorporate the blue energy as well, targeting the main stakeholders that are there, managing them, and then constituting the various verticals of the underwater domain awareness, collaboration between the various private entities, the academic institutions, as well as the various government authorities. How can they come together and develop in formulating a holistic policy framework, we may say. Again, data sharing is one of the most crucial aspect in developing any of the framework, but most of this data may be of strategic and national importance, and most of the countries would not be eagerly waiting for in order to share their data with their neighbors, which may see their adversaries as well. So how can these data sharing mechanisms come up? Like there is the Indian Navy's Information Fusion Center, something like that could be developed, but again, the specifics should be worked upon. Again, when we talk about these data sharing mechanisms, the cloud computing, machine learning, artificial intelligence, all come into picture. So there is a very crucial task in developing the capacity building in the maritime domain, for which the various institutions should come up. Private sector could also step in. Like we could have the Skill India program is there. How can that be utilized in order to train a workforce for the industry standards, developing acoustic capability, the underwater communication, basically adding value to our workforce. And then one of the major thing is developing a national maritime law, which would look upon the various expeditions that are going on. Currently, various authorities are there. There is the National Institute of Oceans, the INCOIS is there, ISRO, like all of these authorities look over the various expeditions. But can there be a common entity which can look all over these projects and have like proper data collection, have some proper policies for data collection, so that we could have a holistic database that can be used in case of any like developmental projects or any kind of regulatory frameworks? No, one of the major thing to know is that all of these systems are for the seabed. But with the India's development of its inland waterways, its freshwater systems, the freshwater fisheries, all this could be how can these sea like ocean related systems can be deployed in the freshwater system, what all changes needs to be done. That research could also very much help in developing the internal economy of our country as well. So these are the major future proposals that could be worked upon. In this matter, or the various sediment classification systems use the various hardware as well. So we have this 2C to understand to share a kind of idea in which we use based on what kind of application, what kind of hardware is required, what sensors are required, should it be deployed on ROV or a UAV as well, and then based on the parameters, what data analytic techniques need to be utilized, supervised learning, uh, unsupervised learning, what kind of processing needs to be done. And then once we have the data, how that data can be shared, how can we use the marine spatial planning, because again the defense forces or the policy makers or government authorities or say the private players all may have different requirements on different hardware on for a different time scale. So how can this be developed? For this, we could have something called an end-to-end technological intervention, which would involve like firstly finding out what kind of data can be collected from online sources. So we have the satellite data or from various government repositories, and then come up for particular applications. So whether for sediment bearing pressure or the benthic ecosystem, what kind of sensor could be there, the synergy between the various devices, and then again what kind of data analytic techniques, and the integration of the marine spatial planning in outreach, visualization and decision making across the various stakeholders that are being concerned here. So with this code, the crazy thing is that we live in an ocean planet and nobody gets that yet. Very less emphasis has been given on oceanic resources and its like proper in development in a sustainable way. It's the maritime domain has a vast potential for its socio-economic development. And with it, I'll end my discussion. Thank you.
Thank you, Romit. Next, we have Rishikesh from IT Delhi, who will be speaking on effective detection in passive sonar systems. And now we have just two presentations left, and post that we can have the questions and comments by the dignitary. Rishikesh, your voice is not audible. It's not audible right now too. Can the supporting team please help Mehul? Can you get in touch with Rishikesh and get the thing sorted? Maybe we can have Rishikesh's presentation afterwards, and we can have Aman Bansal right now to present.
Hello everyone. My name is Aman Bansal. I am a final year undergraduate at the Department of Civil Engineering, IIT Roorkee. I did my summer internship at MRC, and my topic of work was collision avoidance and navigation system using AIS. So let me walk you through the contents of this slide. We'll be first discussing about the need for the collision avoidance system, what are the vessels right now, why AIS data, what's the use of the AIS in the collision avoidance system and my work, and the results and the conclusion part, what's the future scope and the references. So let me give you a brief idea about how and what's the need of the collision avoidance system. Actually, collision in the inland waterways are the biggest threat to the inland water transportation. According to the studies, around 80% of the maritime incidents are due to human error. So there's definitely a need of a technological assistant to assist the humans while taking critical decisions in the close encounter situations. The European Maritime Safety Agency reported around 20,000 marine casualties from 2011 to 2017. These casualties not only have had a significant impact on the environment, but also resulted in the losses of life. So, in the diagram, you can see that over the years, though the number of total accidents have reduced, but the total number of inland collisions are majorly the same as the total number of collisions. So there's definitely a need to study this area and technological assistant to help humans. So what are the available solutions right now? Researchers have worked and they have developed mathematical model to calculate the collision risk index, which is a factor to determine the degree of danger of the ship in that particular region. So because of the trendy deep learning and machine learning, scientists have also tried to use the deep reinforcement learning in the collision avoidance system, machine learning, artificial neural networks, and different other ways. So what I did and what was my work was I use AIS data. So first, let me give you a brief idea about the AIS data. AIS is the shipboard transporter system, which continuously exchanges static and the dynamic data between nearby ships and ships to the shore. So what are the benefits of it is are the data is real time because it is shared over a very high frequency channel. It is not affected by line of sight, rain or sea. So the information and the uh, navigation aid it can provide can be very beneficial in the future. So how AIS data can be used in the collision avoidance system and how I have used is what I considered it. I considered it to be a near collision situation. What I consider that it means is I consider that the two ships are moving or converging at a point, and that point is called the closest point of approach. I calculated the closest point of approach, the distance to reach the closest point of approach, time for the closest point of approach, and based on all these factors, I calculated a collision risk index. That collision risk index is greater than a particular threshold value. Then it triggers the warning system and warns the ship crew. So what I did, I downloaded this vessel trajectory data of May 2023 of Australian region, then pre-processed it and converted the data into the CSV format, removed the redundant values like I removed all invalid data points which are not useful for me or can be beneficial in the model. Then I visualized the vessel trajectories. Here you can see the vessel trajectories of the different ships. I saved to the respective folders. So, then this is the sample vessel trajectory of ship number. So then what I did was if the calculated CRI lies between 0 to 0.4, then it's a less risk scenario. If it's between 0.4 to 0.7, it's a moderate risk scenario. If it's greater than or equal to 0.7, then it's a high risk scenario. Moderate and high risk can also create a navigation system, just like self-driving AI cars. That model can be implemented in the marine domain as well, which could assist the underwater submarines as well the ships to take a safe route in the high risky situation. So what I calculated is I calculated the collision risk index of the ship with the Australian coastline, like the Australian boundary, and here that the ship was away from the coastline, so all the situations are at less risk. And then I calculated the collision risk index of the ship with the nearby ships at that particular timestamp. So three at were less risk and one was at moderate risk because the CRI was greater than 0.4. So in the future and how this work can be carried forward in the future is that we can create or segregate the vessel trajectories according to their risky scenarios like less risk vessel trajectory, moderate risk vessel trajectory, and high risk vessel trajectory. And if we use the bathymetry weather condition in addition to the real-time AIS data and using the historical AIS data and categorizing the vessel trajectories as risky. So in using all those, we can find a net CRI, the net collision risk index, which would definitely enhance the situational awareness of this thing. And this is the thing in which if a ship is moving on a planned route and it detects a warning, then it takes and triggers the collision avoidance and navigation system and changes to a safe route. So this can be implemented in the future, and that could be a major breakthrough in this marine domain. So that's the future scope of my work if it is carried forward. So here are some of the resources. And at last, I would like to conclude by saying we cannot control the winds, but we can direct the sails. Thank you.
Great. Thanks, Aman. We'll get back to Rishikesh and check if he's able to present or not.
Still not audible.
Yes, you're audible now.
Okay. Sorry for the technical difficulty. I'll just share my screen now.
Yes, yes.
Is my screen visible?
Yes, your screen is visible.
All right. Hello, everyone. My name is Rishikesh Nanavre. I'm currently pursuing my BTech in Production and Industrial Engineering from IIT Delhi. During my internship at MRC, I worked on the project Effective Detection in Passive Sonar System. These are the contents that we'll go through. I'll briefly introduce about my project. I'll give a brief introduction about passive sonar, its equation, and then we'll go to the methodology and final result and conclusion. Sonar, short for sound navigation and ranging, is a technology used to detect objects underwater. There are basically two types of sonar systems, active sonar and passive sonar. Main difference is that active has a transmitter as well as a receiver, whereas passive sonar only has a receiver. World's ocean are vast and teeming with life, making them vital ecosystems that require careful management and monitoring. In this context, passive sonar system plays a crucial role in underwater environments, acting as vigilant listeners to detect and interpret acoustic signals of interest. Accurate detection in passive sonar is fundamental for a myriad of applications for marine spatial planning and environmental protection to defense and security operations. The purpose of this project is to enhance the detection performance for effective underwater surveillance. Passive sonar systems rely on detecting and analyzing acoustic signals emitted by underwater objects and sources to gather information about their presence, location, and behavior. In this project, I focus on calculating the transmission losses using the Pyram model and analyzing the signal to noise ratio to evaluate the detection capability of the system. Passive sonar technology works by detecting sound waves emitted by objects in the water, such as submarines, marine animals, or even surface vessels. These sound waves travel through water and can be picked up by hydrophones. Hydrophones are specialized microphones designed to operate underwater. They basically convert the pressured signals into voltage signals. Once the sound waves are detected, they are analyzed to determine the location, speed, direction, and object emitted. To estimate the performance and to assist in the design of sonar systems, we use passive sonar equations. One of the most important parameters is the signal to noise ratio. In decibels, it is given by the following equation presented on the screen, where SL stands for source level, NL stands for noise level, DI stands for directivity index, and TL stands for transmission loss. Transmission loss includes all effects of energy spreading out, absorbed or scattered. This loss term is highly dependent on the parameters of the environment, such as speed, sound speed profile, volume absorption, scattering, bottom loss, surface loss, frequency, depth, etc. It is this term particularly that makes sonar much more difficult to predict and operate as compared to radar, and has necessitates the development of very complex programs and databases to allow its estimation. Here we can see the 4 parameters of the signal to noise ratio in the figure. There is one term called DT, which is detection threshold. The detection threshold is a critical parameter in signal processing and communication systems, including sonar. It is defined as the ratio expressed in decibel units of the signal power to the noise power at the receiver's bandwidth. The ratio is measured in 1 Hz band at the receiver terminal and determines the minimum signal to noise ratio required for reliable detection. When we say when a signal is in fact present at the receiver input terminal, 2 decisions, absent or present, are possible. So when a signal is in fact present, the same 2 decisions can be made. In making this binary 4 choice decision, the 4 possibilities occur as shown in the figure. 2 decisions are correct and 2 are incorrect. They appear at the diagonal elements of the matrix. The probability that a signal is present, the correct decision signal present is made is called the detection probability. Probability that a signal is absent and the incorrect decision signal present is made is called the false alarm probability. The detection threshold depends upon these 2 independent probabilities. To see visually how this works, we'll consider 3 signals, signal 1, 2, and 3, and a noise envelope. Once at the receiver terminal, what we get is a signal plus noise envelope. Here we see T1 and T2, 2 threshold values. Now, for a threshold value of T2, we detect all the 3 signals, but we can also see that some noise is also getting detected. But for a threshold value T1, only the signal of interest is being detected, but not all of them are being detected. So on a plot of a detection probability versus a false alarm probability, which is parameterized by this parameter T detection threshold T1, we get a plot something like this. We see that at T1, as we actually discussed, that the detection probability as well as the false alarm probability is less. But at a threshold value of T2, both the probabilities are high. This curve is actually known as receiver operating characteristic curve, and we'll see about it in later presentation. Now we come to the methodology of the project, calculating transmission loss. Transmission loss estimation is essential in passive sonar. For understanding signal propagation and system performance. The parabolic equation RAM method is widely used approach for low frequency sound transmission calculations. Parabolic equation acoustic propagation models are extremely used in underwater and atmospheric acoustics to solve propagation problems. As we can see, that the only unknown quantity is transmission loss. For the source level idea, we can refer to this figure that for low frequency source level, we get the values nearly 150 to 160 decibels. Coming to the PyRAM implementation, PyRAM is a Python adaptation of range-dependent acoustic model developed by Michael D. Collins at US Naval Research Laboratory. The key features of PyRAM model is it's Python-based, it is computational efficient, method correspondence, and code improvements. By method correspondence, we mean that the PyRAM class contains methods that largely corresponds to the original Fortran subroutines and functions in RAM, retaining the same names and variable conventions. These are the data which I fed to the model. On the left, we have the transmitter receiver location, along with their latitudes and longitudes and distances, the sound speed profiles obtained from World Ocean Atlas, and the bathymetry data. Some of these data were obtained from the MRC repository. Once we run the model, we get an output like this, where the transmission losses between the transmitter and receiver is mentioned in the seabed column. This data is further used in the analysis in MATLAB. The MATLAB script uses the previously calculated transmission losses to determine the signal to noise ratio and plot the ROC curve. It then identifies the location of transmitters and receivers corresponding to the maximum and minimum transmission losses and calculates the area under the curve for performance evaluation. The displayed data provides valuable insights into detection performance of passive sonar systems under different scenarios. So, as discussed previously in the table, for a medium-sized surface vessel, I chose the value of source level to be 155. And for a medium-sized array, the array gain would be 10 and the noise level to be 75 decibels. Finally, the output for the simulation is something like this. We can see that the code is used to integrate various datasets and environment parameters with Pyra model to calculate transmission loss between transmitter and receiver pairs in passive sonar system. And finally, we get optimum locations where we get maximum SNR and minimum SNR values. These SNR values are then used to calculate the receiver operating curves, and that's what. And to assess the performance, we can see the ROC curves to check which location is optimum. Since the ROC curve, the blue curve is more closer to the top left corner and also evident from the area in the curve, we get the optimum location. Coming to the applications, offshore oil and gas industries. In the offshore oil and gas industries, the passive sonar systems can be deployed to monitor underwater equipment and detect potential leaks or malfunctions. These systems are crucial in ensuring the safety and environment sustainability of offshore environments. Maritime security. Passive sonar system can be implemented in various maritime security applications such as coastal surveillance and port security. By detecting and tracking underwater threats such as submarines or unauthorized vessels, these systems enhance the overall security of coastal regions and critical maritime infrastructure. Environmental monitoring. Passive sonar systems are valuable tools for monitoring marine environments and assessing the impact of human activities on marine life. They can be used to detect and track marine mammals such as whales, dolphins, help researchers and conservationists better understand their behavior and protect their habitats. And fisheries management. Concluding my presentation, what we saw in the presentation is effective enhanced detection capability. The analysis of the passive sonar system revealed a strong detection capability in scenarios with high signal to noise ratio. The research finding demonstrates that system excels in detection acoustic signals of interest in background favorable noise conditions. Challenges in low SNR environments and real-world marine applications. The results obtained from this research have practical implications for real-world marine applications. By considering environmental factors and signal characteristics, it is possible to optimize the detection capability of passive sonar systems. This knowledge contributes to the development of more effective and efficient underwater monitoring and surveillance techniques, which are vital for marine spatial planning and marine resource management. And these are the references. I would like to conclude my presentation. Thank you and have a great day.
Thank you, Rishikesh. I guess that was the end of all the set of presentations that we had for today. And in the next session, I would be asking our respective dignitaries to share their thoughts. So first, I would like to call Ambassador Anup Kumar Mudgal, sir. So introducing Ambassador Mudgal, he has been India's former High Commissioner to Mauritius, And currently, Ambassador Mukul is chairing the PICI's Blue Economy Task Force, which is likely to come out with India's policy on blue economy in the upcoming months. So, so I would request you to share your valuable feedback with our interns and your thoughts.
Nishtha, I'm really, I would say, very happy to be part of this exercise. I thank Arna. He gives me this opportunity to listen to these presentations. And I want to really congratulate the participants for their contributions. I'm very happy that, the young researchers are taking interest in the larger ocean affairs. I have been dealing with blue economy and related issues for many years now. And one of the challenges we as task force and even in the steering committee, we were talking about was that how to involve the young researchers, the young minds into the sustainability challenges that the society is facing and is going to face for many more years. So I'm really very, very excited that, these bright young minds are getting interested in this field. Because, in fact, if you look at why we are doing it, in fact, why blue economy, why sustainability, why the underwater domain awareness, when we look around us, sometimes, for example, when we sit far away from the ocean, say sitting in Delhi, or sitting in any inland area where a large part of the world population lives, we are not able to imagine a relationship with the oceans. But just see, for example, what are we talking about these days? We have floods, extensive floods, not only in India, all over the world. We are talking about a phenomena called, say, El Nino, which might have implications for our weather systems. It's nothing new. It has been happening for ages, in fact. We are talking about blue economy, which means economic harnessing of oceans, which we have been doing for ages. A lot of these things are connected to the oceans. And we people of land, we think that everything is determined by what we do on the land. But that's not correct. In fact, a large part of the land behavior is dependent on the ocean. Be it the weather, be it the monsoons, be it the rainfall, be it the other climatic phenomena. So, in fact, ocean, as I'm sure everybody knows, occupies a very large chunk of this land or this planet. And that chunk is causing a lot of things. And sometimes we look at the symptoms, but when we look at the causes of those things, a large number of those phenomena or those symptoms will take us to the ocean where the roots are. Now, if we want, as one of the candidates mentioned, we cannot change the larger planetary behavior, but we can manage our affairs in such a manner that its implications for us remain positive and not negative. And when, for example, talking about, say, blue economy, blue economy is going to play a major role in finding new resources and finding new jobs and finding a lot of things. I'm sure you are aware of the sectors of blue economy. In fact, the current assessment says their value could be something about $24-25 trillion. But in my own assessment, it is an underestimation. And there are estimates which say, job creation and value addition in various sectors of economy, the ocean-related productivity will exceed the land-based productivity. Now, if that is the future we are looking at, then we need to be sure that in harnessing these oceans for our benefit, we make sure that that harnessing is sustainable. Otherwise, the consequences could be very, very serious. In fact, I was looking at a figure, the climate-related impact on the economy for, say, last one decade could be over $1 trillion. Again, in my view, it's an underestimation. We have not really calculated what kind of harm the unsustainability or lack of sustainability may cause to the economy. Even if you go by that estimate, which says about $1.3 trillion in last 10 years, even that amount is a very large amount. Yes. So if we are interested in our own welfare, if we are interested in our own growth, if we are interested in our own progress, I think we need to understand that not only land, much more than that, dealing with the ocean, our acts or activities have to be sustainable. And as I mention always, measuring or assessing the sustainability on land in itself is very, very complicated, where we can see everything, we can touch everything, weigh everything, measure everything more easily because it is accessible, in fact. But even on land, just see, have we been able to manage sustainability? The answer is no. And ocean, where our knowledge of that sphere is almost negligible even today, and the space is much larger. Can you see the challenge? The challenge is enormous, in fact. And most of this challenge lies underwater. Because over water, we only notice the symptoms, but the causes are underwater. The causes are not on the surface. You don't see the causes on surface. Now, today, most of the presenters, in fact, made their effort to explain and understand the acoustic part, which is the sound and the sonar part. But underwater domain awareness is much, much more comprehensive than only one aspect. We'll have to understand and monitor, assess and predict the behavior of the ocean based on, as I say, 3-dimensional or 4-dimensional or multi-dimensional approach. There could be the physical features, which would need constant monitoring, how they are behaving, then the chemical features, then the biological features, then dependent on them, because we are talking about our relationship with the ocean, their socioeconomic impact. Then we have to look at the technology. We have to look at the business. We have to look at the industry. A lot of things. Capacity building. A lot of things. It's a huge area, and it's a new area, in fact. Underwater domain awareness is an endless kind of a sphere where we are just entering, in fact. We are just knocking at the door, right? And we would see the complexity when we just kind of peep through the door, and then we would know how complex it is. But then there is no option, unless we want to live with a very uncertain future, I think we have to understand the oceans better. And in my view, that understanding will not be possible unless we deal with the underwater. Arnab, I in fact, once again, I acknowledge and I appreciate and congratulate you. You are one of the very few, in fact, within India who are paying so much of attention to underwater. Yes. Even elsewhere, in fact, underwater is a new phenomenon. We are talking about marine spatial planning. Now, marine spatial planning, which is absolutely essential for successful harnessing of oceans, that is for blue economy, will not be possible unless we get the real-time inputs on how the ocean is behaving underwater. You know, I really want to appreciate every one of you. Somewhere the beginning has to be made. And of course, this is a good beginning, but a huge amount of work needs to be done in this. And then it's like those blind men and the elephant. Yes, the elephant is a large elephant, and each blind man run the risk of interpreting the elephant based on what part of the elephant that blind man is touching. We need to make sure that we don't deal with the elephant as blind men, right? And do not really be limited by our own bias that one particular element is more important than the other. It's a dynamic system, right? Each and every element can impact the other element, and in process be impacted by that other element or elements. Therefore, now, of course, with the big data systems available to us, I think somewhere down the line, I am more hopeful now. Of these things, when we were talking about, say, 10 years ago, 20 years ago, believe me, we felt we were handicapped because we did not have the tools to deal with such massive size and diversity of data. But today, in fact, thankfully, we have the tools available to us where we can hope to manage the big diverse data which will be required for understanding underwater domain awareness, at least in the areas of our immediate interest. So a large part of the oceans may not be of immediate interest to us. We can leave them to their own dynamics. For example, you mentioned about the man-made noise and then their natural source of sound. You see, we have to understand that the nature has lived with itself for millions and billions of years. But the nature is not used to living with these man-made factors because they come very, very fast in a short period of time. And as a result, the nature is not able to immediately adapt to what we do. You have mentioned so many examples. Today I was reading the New York Times, and there was another case where, this pilot whale, a whole family, about 50 large whales, have come to the beach, and most of them have died on the beach. And one of the reasons is the sound. One of the reasons is this sound pollution in the ocean. But who knows? It could be the chemical factor. Who knows? It could be the physical factor. Who knows? These animals may be impacted by the temperature variation or the chemical variation. Now, these are complicated issues, I think, but because it's complicated, we cannot ignore them, right? So once again, Arnav, I really congratulate you and your team, and more than everything else, these youngsters who have started taking interest in this very important field. I'm sure we are looking at we're looking at great amount of hope. Because once the youngsters start taking interest in a challenging issue, I think you can believe that a solution is, at least solution is coming. It may not be tomorrow, it may be day after, it may be maybe a year, more than that. But at least you know that things are going in the right direction. Thank you very much for giving me this opportunity to listen to these bright presentations and at least comment on that, my view of this blue economy. Thank you so much.
Thank you so much, sir. I really appreciate your very kind comments, and we will definitely continue our effort, and we would like to make a separate presentation one of the days of your convenience, and of course Admin Verma sir and Shenoy sir also, I would request them to join. We'll fix that. We have built now a larger framework for MSP now, sir, and as you can see, every project has a will have a manifestation in MSP, but now it is required that we stitch together everything. So we are working on a larger framework for MSP, and we would like to demonstrate that to you. Sridhar is working very hard on that. We have a very dedicated team working on that specially. So we will talk about that, sir, in a different time. Thank you so much, sir.
Thank you so much.
Thank you so much, Ambassador Muttal, sir, for your kind words and for inspiring the students who have presented today. Next, I would like to call Vice Admiral DSP Verma, sir, for his views and comments. So introducing Vice Admiral DSP Verma, he is the former Director General of the Strategic Submarine Project and Chief of Material in the Indian Navy. So I would request sir to share his views with us.
Yeah, thank you very much, especially to all the participants for having taken me back several years to my younger days. I was just recollecting 1974, working on underwater. That is how much? 26 plus 23, 49 years ago in IIT Delhi. And at that time, I was doing my radar communication, but I said I'm a seaman, so I must do something with the sea, and that's when we started. I started working on the underwater side. I couldn't find solutions for passive sonar because it's difficult, so I started attacking the attack sonar, and first, and then passive sonar was simultaneously. I had a group of young people who were also enthusiastic. I had the domain, and of course, since I was a student, I had the thing of the library and others to go ahead and do it. It's been a long way. The problems are the same. Today, what you have the tools. You have better computing speeds. You have, better data available. Your AIs never existed in those days. So you have data which you can collect, we can use. And I'm glad that Arnab is taking this forward. I, of course, have been telling him for a long time that he's building a human resource, which is very important. Because I know unless there are people to carry forward your ideas and things, then it's not going to happen. That's why it's taken 50 years. Because in between you'll have, if the momentum had been kept up, though of course we had young people in which we had Varki, and after that I think Arnab. So there was a gap between Varki and Arnab. Arnab has been continuous there. So a lot has been achieved. Today I was very happy to hear on all the each participant, each intern or fellow has concentrated on a bit, which is the right way to go about it. Because as Arnab mentioned towards the end, that we are stitching together all these bits, because you can only do that much in that much time. There's no point doing this, which is very good. Now coming to I'll have to connect up my power source, otherwise I'll be missing very soon. Just one. Yeah, I'm connected. So since I've heard some of them before during the COEP and today, uh, I just want to make a few observations. Again, maybe because lack of knowledge from my side, or lack of understanding or whatever it is. Okay. Now, marine spatial planning is important, and today we had Sanskar talking us about the model for what is this called, where you have the wind simulation and all that added. But there is one. His was the three-dimensional ocean ambient noise mapping tool. Here, the most important thing is the data collection. We are depending on AIS, which is the best we can have today. But there's an element in AIS which we are going by what is thing. You definitely don't know the propeller characteristics of that particular thing to estimate the noise, right? However, you got a model. It's very useful in the next one where Akshita said for acoustic transmission laws for ship design, where the person who is designing knows what propeller to put. So he can use that same thing there, right? However, the in the AIS data, where what is thing we use the speed of the platform, but the cavitation thing we won't know. So could we in our model have various cavitation this thing put so that it becomes a thing for testing? That is one. Second, since we now have a good idea about the traffic, especially the AIS traffic around the Indian Ocean region, which you have been mapping regularly, there's enough data, etc. Can we validate it? Because now I've seen that wind and sedimentation can also be put because you're using the data from, I think, some other boys, Omni and others. Can we have some not real time, some real time thing for noise at certain time just to validate our system? Why I'm saying this is in another seminar, NIOT did mention that they have a lot of boys, for the disaster, thing for tsunami thing, etc. Could we have a hydrophone and then get that data and of that day, of that particular thing, etc. And since you have AIS data, could we do some kind of a matching? I had a talk about this with the director NIOT when I met him in December. He said they have a hydrophone. I said, then what are you doing with that information? Why can't think? So I had mentioned to Dr. Das that we must go across there and see if we can tie up this, because your tool will become that much more powerful. That is the. So I both Sanskar and Nakshita pretty good. And Nakshita's thing should be moved forward because I can see a great potential for ship design. Because the designers now, if we have laws which says that you can't make this much noise, right? So he will know what is the noise he is making at a particular place, etc. By finding out the acoustic transmission laws. So this will be a very useful thing for ship industry, ship designers, and then obviously ship industry. So these two are thing. Precipitation is okay, fine. This thing. Rohit did mention about sediment classification, the importance and the requirement for sediment classification. He did mention, but the question is, how are we going to do data collection for this thing? How are we going to do data collection? I'm sure it will be the next part of your big project. That is one thing which I'm. The other one was collision avoidance system. I mean, as I always tell you, in good old days, we never had any of these. So when we used to be sailors, we used to use what's called a Battenberg. I think he was a first sea lord or something who made the Battenberg, which is basically you're doing a relative velocity problem. that chap is doing this, so you know when you're going to hit, so you take avoidance, correct? Here you're using, but then for that you should know where he is. So you used to use radar, etc. Here you're not using radar, you're using AI's information. But my only problem is, what is the frequency of the AIC information? Because that would sort of that is an important thing. The AIS data, what is the frequency? Because the data that comes out from it, as I understand, right, is it continuous? The date, of course, the transponder is on, but the information that put on that, is it continuous? I don't know. So that is one. What is the frequency? Because your avoidance system will depend on the report, the frequency of the report that you're getting. Am I right? I don't know. Somebody should say. I'm not talking there.
No, sir, you're right, sir. Now we get, it's possible to get updates every 5 minutes. AIS.
Okay. So 5 minutes is good enough.
Yes, it's good enough.
But only thing is, we don't have the AIS on board. That is the challenge. So the challenge is ensuring that each vessel has a AIS on board. Right. If that is done, then the thing is the on the passive sonar detection, the effective detection algorithm. Here, the issue of source level, that is the level of the noise maker, right? Because that's how in your equation you have said that source level is known. So obviously you know the noise makers, but do you actually know? So your tool could be that if the source level is so and so, then your passive detection would be this, because I already have the medium thing to work out the transmission loss. The DI and DT is possible. I mean, that's calculatable. But the issue is, and of course, one more is for calculating the transmission loss, you should know the range of that guide. You should know the distance, right? A passive sonar does have method of doing it. They do triangulation and get the thing, but a hydrophone will not. So I saw a hydrophone there in your thing. So I think we should, since it's said that in the equation you have only unknown is transmission loss, I said here source level is also unknown. For a specific source level, yes, the other things are available, so you can transmit. That's it. So once again, actually I'm thrilled because for once I'm seeing, not once, I'm in the MRC and with the interns, etc. One, I'm able to connect up with my old, memories. Second, I wish 40 years ago, 48, when I was working, we had as many enthusiasts. I was a lone fellow working, and with some help from Anup Vyas and Behel at times, because they had their own thing. They were in radar signal processing. But I think we moved a long way, and I'm very happy that a lot of people from IIT Delhi. So that means the underwater thing system there is working. Something that we set it up in 78, 79, and it's working. So it's pretty good, and I'm very happy, and I'm always thrilled to associate with it. One more thing, Arnab, I think you have to make a trip to NIOT because they are doing a lot of work on all these things, and we should barge in. And then the third thing is which I mentioned to you, the digital ocean. The Inquis thing. How do we get data? How do we step in, get data from that? Because this will all be very useful for the interns to, polish up what they're doing. Again, good work as usual. I think I'm tired of seeing good work to Arnav for a long time, 50 years almost. No, sorry, 25 years. Yeah, as far as Arnav is concerned, I think only about 15 to 20 years. Very good. He's always doing good work, and I'm so happy he's got a good band of people helping him. Thank you very much. And I think that's it. I hope I've been able to contribute in whichever little way it is. And I'm always available whenever you people need me. Thank you.
Thank you so much, sir. We definitely take note of your points. And now we have Shenoy sir speaking after you. So he has facilitated our interaction and collaboration with Ministry of Earth Sciences and then multiple labs under that. Thank you very much, sir.
Thank you.
So, sorry to interrupt. Before we move to Shenoy sir, so Admiral sir, on your comment of the AIS data, so what we are doing here is that we are performing vessel trajectory reconstruction. So using the historical data, we reconstruct the path that a vessel has taken in the past, and as well as predict the path that the vessel is taking instantaneously. So agreeably, there's a gap between the AIS data transmissions, but we are hoping to bridge that gap using that vessel trajectory reconstruction using the random forest. And it might not be as accurate as AIS data, but hoping that the vessel would take the same path in the given waterway. We are hoping that the vessel trajectory reconstruction would allow us to bridge that gap in AIS data transmission. And in the future, like upcoming part of this work is to basically using the same historical data, identify the pain points, the areas where there has been accidents that have happened, or where there have been some amount of collisions or some kind of more amount of risk, and use that as an additional parameter for the collision avoidance system, apart from just the closest point of approach uh, CRX, closest point of approach risk indexing method that we're using. That's it, sir.
Yeah, thank you. I think you hit the nail on the point that we are not just going to use the close approach, the sea. You also have to have the vessel behavior previous to this few things. Because as I said, if the IAS stops or the fellow decides to take a break and go to port or starboard, that information, normally in a radar, you're able to capture it. But in AIS, that's why I asked you for the frequency of thing. Yeah, good. You fellows are on the right track. It's just that I had to tell you, I also understand. So I just said that. Okay.
Thank you, sir. Next, can we have Dr. Satish Shenoy to share his thoughts with us? Dr. Shenoy is the former director of Indian National Centre for Ocean Information Services, which is in COIS. So I would like Dr. Shenoy to share his kind words with all of us.
Thank you very much. Let me thank MRC for giving me an opportunity to be associated with the presentations from the young interns, the work which they had carried out for the past few months as summer interns. Maybe for 3 or 4 months they have done all this work. And let me also congratulate the interns for really doing very good work and bringing the new technologies, new tools, in fact, like AI, machine learning, and marine spatial planning in underwater domain issues. That way, I really enjoyed these presentations, and I'm glad that the new generation is bringing a lot more value to the system. In fact, Ambassador Mudgal as well as Vice Admiral Verma has made very pertinent points about the need for underwater domain during these years, during the times of blue economy and the sustainable development, as well as Admiral Verma stressed on the data requirements, etc. I fully agree with their comments, and I congratulate the youngsters for taking up these problems and coming up with various solutions. However, I have a couple of suggestions because I heard the presentation by Sanskar Sony on the three-dimensional ocean ambient noise mapping tool demonstration. Because he is trying to utilize this tool to identify various types of noises, ambient noises, as well as the artificial noises like from the ships, etc. That's a good beginning. There is no doubt about that. However, I think Additionally, you may have to create the signatures of various noises. Then only you can identify. For example, if that noise is coming from a particular type of fish or from the marine mammals like whales or those kind of creatures, and from the ships of various types, because each type of the ship will produce different types of noise. So I think there is a vast application of AI ML as well as machine learning, because earlier days we used to do simple Fourier analysis to find the
FFT
spectra of
analysis.
frequency. Yes, because that is the tool which we knew and which we
Yeah.
had. But these days, with the availability of AI and ML, the machine learning, I am sure these noises can be identified much better. In fact, I think the AI ML started its birth from applying on the acoustics, speech analysis, as well as capturing the noise and identifying from where that noise and whose noise, what's the source of that noise. So I would suggest that such aspects also should be brought in these kind of projects. Maybe the time is too short for the present interns to deal with all that. So in their future work, or maybe in the new interns can take up these kind of issues. Similarly, the presentation on wind and precipitation noise, there also I feel that these kind of signatures, a library of a signatures has to be made and produced, so that when you analyze the data to identify the source, these signatures can be matched, and it can be identified very easily in that case. I enjoyed all those presentations, though I am far away from understanding the passive sonar systems and avoidance system for inland waterways. But definitely these are very much required, and the new ways of looking at these issues have been brought out by Rishikesh as well as Aman Bensal. So these are very important issues, and I have nothing more to comment on that, because my field of expertise is very far from these two aspects. Otherwise, I enjoyed and I had a opportunity to listen to the younger generation, how they think and how they are dealing with the problems which are common and persisted for the years. So I'm sure that they will be able to make much headways in these aspects, especially when the country is looking at going at a faster pace in the blue economy implementation projects, and the sustainable development as well as sustainability and the climate change aspects. They are very important, and these kind of tools which have been developed by these youngsters will be definitely useful for tackling many of these aspects. So let me once again appreciate as well as congratulate all those presenters for wonderful presentations, and I really liked the way they think and they solve the problems. Thank you very much.
Thank you so much, sir, for your kind words and for sharing your insightful notes. Next, I would like to call Captain Sudhir Subedas, sir. He is the former Joint Director, DG of Shipping. So I would like him to be here and share his comments with all of us. Sudhir, sir, can you hear us? I think sir is trying to connect, but he's not able to speak.
Good afternoon. Good afternoon. Can you hear me?
Yes, sir, we can hear you.
Good afternoon. Good afternoon, Mudgal sir. Good afternoon, Admiral Verma.
Good afternoon.
I've heard the presentations during the morning session, and happy to recall that application of this technology and MRC work will particularly go long way in the applications for safe navigation and secure navigation in inland water transport. I'm looking forward to associating with technicians, classification societies, Inland Waterways Authority to help the team go forward from the presentations and outcomes that were displayed with very fruitful results that is possible to make good use, particularly in managing depths of water, sedimentation management, and its application in dredging works, which is critical in developing the inland waterways. Thank you very much.
Thank you so much, sir. Last, I would like to call Sridhar to share the closing remarks with all of us, and after which we'll end the day one of the webinar. Thank you so much.
Thank you, Nishta, and thank you all to all the dignitaries for their wonderful comments. As we all know, the amount of work that the interns have done in the 2 months, it's been good. All of them have explored some really new dimensions to solving these problems, and I'm really we all of us at MRC, we're really happy to see the progress that all of you have made in a short span of time. I agree, it hasn't been easy. It hasn't been considering the fact that the underwater domain awareness as a field, or underwater domain per se, it's as a field, is extremely niche, and many of you, although had some understanding of signal processing, some understanding of machine learning, didn't know anything related to this particular domain, and it was something new for all of you to pick up. But regardless, I do sincerely hope that you guys have learned something new, something that contributes to your overall uh, uh, tech and product understanding. And we are extremely happy to have you with us for this internship, and we are glad that you have performed so well in this part. And this seminar, showcasing your work, it has been really good. You guys have made a good amount of showcasing of your work and explained your work extremely well. And thank you to all the dignitaries for being with us here, taking the time out and understanding, and giving valuable comments to all the interns and everyone who has done the work. These comments are the most valuable part for us, that allows us to expand further on the work that we have done, add improvements and make it better, and also understand some real world application of the work that we are trying to do. We'll continuously keep in touch with all of you, respected dignitaries, and we'll try to enhance our work further and seek out your guidance for the same. Thanks, Nishta.
I think we can the day one of the webinar now, and tomorrow at the same time we'll be meeting again with the next set of presentations by our interns. So thank you so much. Thanks everyone.
Thank you. Thanks a lot.
Thank you. Thank you very much. Bye.
Hi, Murli.
Hi, sir. Good to see you.
Acknowledged.
DSC for last month twice.
Yeah. Okay.
Okay.
So